All right. So, hi everyone. Let me remove this while we are actually at it. Hi Nitin, how things going?
Hey, pretty good. How have you been?
Good. I just had some internet issues, so I was not able to. I had a little bit of a scare before getting in, but anyway, I think we're fine now.
There's a two
And I
minute
hope
delay. That's okay.
that's okay. It's not so bad. And in any case, I think we have a lot to talk about. But anyway, so yes. So first of all, folks, thank you for those of you who are tuned in to the live event. If you're not, you can always watch this later as well. So today we're going to be looking at something that it's been quite an interesting approach, wouldn't you think? Don't you think it's been quite an interesting way at which we arrived at this particular solution of ours or this particular approach?
For sure. This was an idea that was generated after hours and hours of conversation with our fellow teammates, both Sharath and Tilak, where we had to argue quite a bit. We had to figure out the entire architecture. Then we got back to you. Then you made a few suggestions and recommendations. So we had to go back to the drawing board again, make a few changes, and But hey, we managed to do this entire thing in like under 38 hours. So kudos to both Sharath and Tilak for making this possible as well. Absolutely.
Yeah, absolutely. So, what we're going to be talking about today is essentially about Kubernetes threat hunting. So, for those of you who are not familiar with the topic of the day, topic du jour is Kubernetes threat hunting. So, we're going to be looking at first of all, what is threat hunting on Kubernetes, and then we're going to be looking at first of all how we came up with this idea. What is threat hunting on Kubernetes? How does it work? What is it supposed to do? And of course, with it would not be V45 AppSec engineer session without demos. So we're definitely going to be having some demos in there. I think Nitin is ready and set up with some demos as well. So we're going to be doing this and we're going to have some fun along the way talking about this. So just to give everybody a little bit of an introduction, about a month back, was it 2 months back, or maybe a month back, we had
Almost a month back. Yeah.
yeah, just a month back. We had an event in V45 called the FedEx Day, where we divided the company into multiple teams, and each team built something in 24 hours. So this time, since we were all remote, we decided to make that 48 hours, and teams have to build something in about 48 hours. And the winning team was Nitin, Sharath, and Tilak, who came up with a Kubernetes threat hunting tool that we have since called Kranthi. So Kranthi basically meaning revolution, and hopefully this is revolutionary, quite interesting for all of you to look at as well. What did you think of the name Kranti? I don't know. I don't think that was your first choice.
That was definitely not our first choice, and I think you essentially recommended the name to us. We had a complete different name, yeah, which was not that great. But yes, we definitely need a better name, and we still need a logo. So if any of you folks are good at logo designs, let us know in the comments below, and we might as well reach out to you. Or you can
Yeah.
once we put this on GitHub, you can help us out maybe.
Yes. We intend to. By the way, yeah, this just that Nitin is saying we intend to open source the project. Once we clean it up a little bit, I think we still have some rough edges here and there, but I think we intend to open it up quite comprehensively after this and keep this available to the community. So before we get into the whole thing and before we start with the demo, let's look at what Kubernetes threat hunting is. I do have a few slides that I have kind of put together here. This is mostly from stuff that we talk about to a certain extent in our trainings, but I just thought we'll do a few slides and then, of course, Nitin has a very interesting demo lined up for us. So, basically, what we're going to do today, we're going to look at, first of all, how this works. First of all, what is Kubernetes threat hunting? What kind of threats can one expect to find with in a Kubernetes cluster? Which I'm sure all of you realize by now is quite a few. It's not, it's not without its issues. So definitely, you can find a whole bunch of threats in a Kubernetes cluster. And then we look at the approach that we took to essentially identifying these particular threats, and of course how we actually went about building this system. So one of the cool things is that I think we've built this system in a very scalable way. I think the team has come up with a very scalable approach to running this. So I really like the entire approach that we've taken for this. So I'm really excited to talk about it, and I'm sure you are excited to see this as well. But let's just get a little bit of theory out of the way and then kind of get into the whole thing, right? So let me just share my screen, and I hope I'm sharing. Just give me a second. It's always a pain when I'm doing this because I end up sharing the wrong screen, and that always okay, in window looks like okay. Here we go. Yeah, so I think we have this here. All right. So just a quick. I don't have too many slides. I'm not going to make this a death by PowerPoint things. And just so basically, one of the things that we went with was that look, Kubernetes is a distributed system. In fact, I've always said this to everybody that I train, and I think Nitin, we have also spoken about this internally. Is basically when you're running Kubernetes, you're running your own cloud, right? So a lot of what you see in the cloud or in AWS or Azure or GCP, you will see that you're kind of running a lot of that, like some infrastructure like that when you're running a Kubernetes cluster, because it's distributed, it's elastic in nature. At least it's meant to be that way, especially if you're managing it the right way. It's supposed to be fault tolerant, and all of those good things that you like in cloud infrastructure is what Kubernetes is all about. And when you're running Kubernetes, you are really getting that feel of running your own cloud in a very serious way. So let's talk a little bit about uh, what is this? What is this idea of threat hunting? First of all, we want, in this case, what we wanted to do was to identify security issues or identify vulnerabilities or exploited systems or exploited pods and so on and so forth through non-intrusive, through mechanisms that are not necessarily, they may not be real time as it's happening, but at least more like uh, things that have happened. We want to get an idea of what has happened, maybe to prevent things like that from happening. Right? Was that your idea when you went into this project as well, Nitin? What was your thought process when you first
Sure.
went into this project?
So we had a bunch of things that we thought of doing, right? So runtime security, in our opinion, at least, is kind of a solved problem, right? So we have open source projects like Falco, we have open source projects by AppSec like Tracy. So runtime was a pretty solved problem, so we did not want to go after that. And we did not also want to stitch multiple tools together and just create one more framework, which can essentially, run bunch of tools, some other from some other open source projects. That, at least for the team, our team, that when we were building it, that felt like a pretty easy challenge, and we did not want to go that. Threat hunting, on the other hand, is something that was new to us as well. Like, obviously, being from the security industry, we have heard of threat hunting. You and I both, and all of us from the team, have attended a bunch of talks about threat hunting at multiple conferences where we train at, and we have a good idea of what threat hunting is, but we had never actually implemented it in a project of sort, and especially for
Especially a cloud
Kubernetes.
native project. Yeah.
Exactly. And for Kubernetes, at least we could not find any open source threat hunting tools out there which were well maintained and well developed. So we were like, hey, you know what? This is a great learning opportunity. It's essentially like, a 48-hour sprint where we're not going to be sleeping all that much. Might as well learn new things, learn about the new tech stack, which we are going to be talking about very soon. And that was essentially, how we came up with this project.
Right. So yeah, so when you're looking, so what I think what we wanted to do was leverage logs or audit events that are triggered by or that are generated by Kubernetes as an ecosystem, and leverage that to identify security issues or exploited pods or exploited apps or what have you, right? So the idea here was to use the massive, in fact, most people don't realize this, but the logging infrastructure or the logging capability, the tracing capability, the entire event framework around audit logging that Kubernetes provides is quite powerful. It's quite huge. So we wanted to leverage that and get into the whole thing, right? So we wanted to be able to leverage the entire logging framework to do this. So that's where this came in. So Kubernetes generates a bunch of logs. Obviously, when you're on Kubernetes, it generates logs just like any other system. So obviously, one of them is the API server logs. This is the kind of the mothership of this is the control plane logs, right? So this is equivalent, if you are from the AWS world, this is equivalent to your cloud train, where each and every event that is invoked, so each and every API functionality that is invoked is typically a log, or you can log it, or you have the ability to log it, create some kind of a trail from it, and be able to analyze it later on. Of course, you have logs from workloads. So let's say you're running applications like pods and sidecar containers and all of that stuff. Then you obviously have logs from there. And then, of course, you have logs from the worker node itself. You have container runtime logs, you have sys logs, you have all of that stuff. Now, we're not going to get into the worker node bit so much, I think, because I think that's largely an issue that it's a little lower abstraction than what we were looking to do, which was mostly Kubernetes. So basically, and again, here we focused on, I think, two sets of areas. One is the workload security analysis and API server based security analysis. So that's really, I think, what we went after in this particular project. So if you look at it, Kubernetes just gives you a pretty huge ecosystem, or a pretty comprehensive logging system for the API server, right? So API server can generate logs, and you can have those logs captured as an audit policy and things like that. So this is essentially what an audit policy looks like, where you can essentially have requests and responses logged in a particular file, or you can send it to a socket. Nitin's probably going to demonstrate this solution as part of our solution, as part of the Kranthi framework a little bit later. But the idea here is that all of this can be pushed to either a file or a socket, where that socket can process it and do something with it. That's what we ended up doing, I think. So where we had the request come in and we had the request response, and each request response was processed by our threat hunting tool that was looking for specific types of rules that were triggered by these requests. So it's basically like looking at a runtime series, or series of events that are happening across the Kubernetes API server or the control plane, and then basically trying to analyze whether there was some security issue that was that, or there was some vulnerability or some exploited system that we were able to discover along the way. So basically, this is an audit log example in Kubernetes where you have, and this you see with a lot of cloud native systems, right? So if you go to AWS, you see CloudTrail logs, not exactly the same, but obviously a little similar to this. You have what is the source, what is the destination, what is the functionality access. So this basically, in this case, it was for the persistent volume claims, and it's basically, since Kubernetes is an HTTP API, or it's an API, you get all of the logs that are invoked against that particular API. So if I create a new pod, it obviously is an API function that is invoked that generates a log. If I create a new service, if I delete something, that generates a log. All of this can be set up as a policy. That's basically what we wanted to do. So I think the idea was to be able to look for these kind of things, right? So rogue agents, anonymous cluster access, and of course, Nitin will showcase this as well. So all of these things are things we wanted to identify, right? Things we wanted to identify as issues. And we've kind of, I think one of the things that the team did really well here was to create this scalable framework. So we used Open Policy Agent, and I think we have frameworkized it to a certain extent, where you don't need to hard code these rules in any source code. You can just write OPA rule sets, and you can start getting new events, or start targeting newer attack vectors or newer exploits. So for instance, let's say you want to be able to identify something that has some other type of event that is not supported in our current rules, and I think it's quite easy to extend. What do you think, Nitin? What do you feel about that?
So Rego honestly is something that an open policy agent is something that we talk about in our trainings a lot when it comes to policy in a Kubernetes cluster and how to integrate it with the OPA gatekeeper and all of that. But we actually wanted something a lot more scalable, because one of the
first issues that we faced when we were building the solution was it started generating a ton of logs. I'm talking 300,000 logs in under 30 minutes. And we had to have a very scalable approach of essentially parsing some of these logs that were hitting our webhook, which we had created. And at the same time, it was analyzing it and filtering it out and essentially telling us whether it believed it was dangerous or if it was not dangerous. So I still remember our first idea was to go ahead and write it in something like Python. But you then got back to us and recommended, hey, you know what, that's probably not going to scale all that well. And if you go ahead with the entire threading approach, it's going to become a complete mess. And you were the one who actually recommended and suggested OPA. So question back to you, right? So what are some of the use cases in which OPA can be useful that's not being leveraged enough? I'm sure this is one such use case. But first of all, do you think it's being used enough? And if not, where do you think it should be used a little bit more in our industry at least?
Yeah, so yeah, it's a good question. OPA for me is like the shit, right? It can solve everything. In my opinion, OPA is something that can solve all problems, at least for me. So I mean, I know it's a little naive as a statement, but let me kind of drill down. So OPA, for those of you who are not aware, is a policy as code framework where you can write up your policies in this specialized domain-specific language called Rigo, and you can start enforcing policies based on the kind of policy statements you've written there. So a request comes in, it checks against a particular policy and checks whether the request violates anything in the policy, and then it either allows it or denies it. Now, OPA is a general purpose policy framework, general purpose framework that you can use for anything. So anything that involves allowing or not allowing something, you can use OPA for. So you can use it for access control. You can use it for things like we have done, right? So if you want to be able to filter out certain types of so what you said is exactly what you can use OPA for. So you want to examine something and check whether it matches rules or it does not match policy or a rule or whatever you want to call it, right? A certain thing that you want it to match or not match. If it matches, then yes. If it does not match, then no. So in your case, you've used OPA as a way to say that, look, this is an event that has come in from my Kubernetes API server. Tell me whether it hits your rules, and your rules contains all the bad things you wanted to match against. So you can literally use OPA for anything, right? So which is involving making a decision true or false about any request that comes in. So you can use it for web applications. I've used it in API gateways. You've used it this way. I've seen use cases of OPA with SSH, with Kafka, with anything that can that has the ability to create or has the ability to process or deal with hierarchical data sets like JSON, YAML, so on. So yeah, so this is basically I think why I suggested you go with OPA, and my choices have always been flawless, and I think my choice in this case has also been flawless.
Moving on.
Humble brag. So basically, this is what we wanted to find. So we wanted to essentially detect these sort of security issues. At the same time, make it, I think one of the things that I liked about the project was it's interoperable with Falco. Now, Falco is something that a lot of people in the Kubernetes community use, right? A lot of people use. Can you just give a little bit of, what does Falco do and why did you use it? What essentially was the goal here?
Absolutely. So with these rules and the hypotheses that you see on the screen, these are essentially some of the things that we can detect through logs. But again, a huge set of attacks cannot be detected through just this. And we wanted visibility into those attacks as well. Those meaning the runtime security issues that typically happen, right? So things like somebody running a bash inside a pod that's running on your Kubernetes cluster, that's probably dangerous, right? So you don't want random folks being able to exec into your pod. Somebody gaining access or reading a dangerous file that you've defined on your Kubernetes cluster. So in our case, one of the things that we look for is anytime somebody tries to access the service account token, which is automatically mounted by default on Kubernetes. I still don't know why they do that. But anyways, as soon as it's mounted, if somebody tries to read it, it goes ahead and gives us it throws a potential warning, right? So there are a plethora of runtime security issues that constantly pop up on a Kubernetes cluster. And just having these set of hypotheses which we've implemented, just having this in place, in our opinion, would not have given that much value, right? So you were still missing out on some of the potential security issues that were caused because of runtime security issues. So we decided, hey, you know what? Those are anyway generating logs as well. And typically, Falco is either one of the cool, interesting features about Falco is you can push these logs to something like Slack. Something that we teach in our trainings at Kubernetes Security Masterclass is how to integrate Falco with Elasticsearch and Kibana, right? So if you want to have an entire visual process. So since they are anyway generating logs, and we had a pretty good solution to parse these logs with OPA, which is like, hey, why not leverage those logs as well? And we've had quite a bit of experience playing around and using Falco in production as well. So it's like, hey, this gives us a lot more visibility into the runtime security. So we're not just solving the log level issues that can potentially happen. We're also trying to solve the runtime security issues, and we're looking for potential, misconfigurations or dangers in the runtime security as well. So that was the key factor in deciding to go with Falco.
Yeah, absolutely. And I think one of the things that, so just we cover a lot of this in our training, especially Falco. I think we have a pretty big lab. In fact, just to let everybody know, we are running for the Cybersecurity Awareness Month. We're running a pretty huge discount on AppSecEngineer's plans, especially the annual plan. So please do check it out if you're interested. We are launching a whole bunch of new courses, and a lot of Kubernetes content's already up there. So definitely take a look. Anyway, so coming back to our thing here. So basically, we are using the two logs that we were talking about, right? We're basically using the control plane audit logs. The second thing we're using is the Falco logs, right? So Falco is already a pre-built system, which works kind of like what OPA does, right? It has rules, and if those rules trip, you have an event that is generated from Falco saying that, hey, seems to be some kind of an intrusion, or there seems to be some kind of a security event that's generated. Now, what we are doing with the engine, so all of this is being processed by a webhook. Now, that's the cool thing about Kubernetes, right? There's literally webhooks for anything. You can create webhooks for literally anything. You have validating webhooks, you're mutating webhooks, you have audit related webhooks. So if you want to send, it's such a nicely laid out system that it allows you to trigger events or generate events for anything and have whatever you want to consume those events. I really love that. I'm a big fan of webhooks. I've been a fan since, I'm sure, the Orchestron days, where we used to build Orchestron, and we were I think we are the only ones who still support that kind of a webhook based system.
Yeah.
And so webhooks are really great because it allows you to integrate these extremely diverse systems without too much difficulty. And Kubernetes by default gives you like these the entire framework that that is super webhook friendly. So that's what we did, and that's what you folks built out as well. And open policy
life so much. Sorry,
Yeah.
it makes life just so much more easier, right? So imagine not having webhook. Like the typical approach that you would have to do is probably deploy your own daemon set, collect the log, and then write a logic to go ahead and push these logs to a different server somewhere, and how all of that. I'll be showing this very soon, but having to push your API server logs to a webhook is literally changing two flags in a manifest file, and it's that simple.
Yeah, that's the thing, right? Kubernetes, that's why I say it's like running your cloud, because it gives you the entire, it gives you the lay of the land. It gives you those batteries and the entire infrastructure for you to use it. Yes, it gets a little complicated, and I'm sure it's not the simplest thing in the world for a lot of people to manage, but I think it's damn good because it gives you all this functionality. All you have to do is, of course, figure things out and run it, and of course, try and leverage it as best as you can. that's definitely something we need to do. So tell us a little bit about why macro meta. I mean, I know why macro meta me, but why macro meta? Why did we go with, and why did you folks choose macro meta even though you were not aware of it before this? And why, yeah, what is the reason? What was the, why was that database there?
Sure. So macro meta, I think few days or few weeks before the entire FedEx day, I think you had given us a brief demo because we do plan on building one more open source project and that leverages some of these capabilities of similar databases, not just macro meta. So at least for the three of us, we were like, hey, you know what, this is a great learning opportunity. We definitely cannot go with a traditional database like a SQL or a Postgres, right? So that would not have worked. And from a scalability perspective, having to manage that and scaling that tends to become a huge issue. And the initial idea was to either look at something like Mongo or Dynamo. But at the same time, we were kind of familiar with Mongo and Dynamo because we do use it at least in quite a few projects, and we've helped multiple organizations implement them securely as well. So this, on the other hand, it felt like a good learning opportunity, and also you did kind of recommend and you played around, and you also had implemented your own data set on Macrometa before FedEx Day. So like, hey, this is a great learning opportunity, so why not just go for it? And it worked out really well, by the way. Right, so using this database from a scalability perspective and from a querying perspective as well, it made things like stupidly easy. And since we were blocked in terms of the time that we had, we did not have much time. Leveraging this, felt like the right approach at the nth hour.
Yeah, I mean, for me, graph databases are kind of becoming a no-brainer, whether it's Macrometa or Arago or Fauna or any of these, even Neo4j, although Neo4j I've not particularly enjoyed so much, but it's still definitely better than most of the way I see it is that all of these things are relationships that need to be graphed. They have, you have things that relate to other things, and you want to be able to query these nodes and edges, and graph databases make your life a lot easier. Macrometa gives you that. So that's, I think it's definitely makes a lot of sense with using Macrometa. So yeah. So right, Nitin, I think it's time that we looked at, we actually, the rubber meets the road, and we look at a demo of Kranthi and how it actually works, and the whole threat hunting element of it and how it actually works. So let's, I'm going to stop sharing my screen, and you can start sharing yours. And let's give the folks what they're here to see, which is a demo.
I'm hoping this works. Demo gods, I don't think they favor me all that much, but hey, it's okay. I've set it up this time just to be on the safer side. So I'm quickly going to explain what I have here and some of the changes that I've made. Again, we are going to be releasing this project open source and probably putting it on GitHub in a few weeks or so. But this is typically how you go ahead and set up, right? So one of the approaches that we took was to use our own Kubernetes cluster, right? So instead of using something like EKS or GKE, what we decided to do was we set up our own Kubernetes cluster on our AppSecEngineer lab portal, right? So all the AppSecEngineer folks, I'm sure you recognize this screen right here. So this is our lab portal that we typically use for our trainings and all that. So what I've essentially done here is I've gone ahead and set up my own Kubernetes cluster. I have a couple of pods running here as well, right? So one of the pods that you see here is the Falco. Now, typically when you set up your own Kubernetes cluster, especially on a server, in the etc directory under Kubernetes, there are going to be a bunch of files that are automatically created. Now, one of the things that we need, and something that Abhay suggested, was the audit policies, right? So we need to go ahead and set the audit policy. So the audit policy is something that I have put in the PKI directory right here. So let's quickly go over this policy and see what's happening. So again, when it comes to auditing in a Kubernetes cluster, there are multiple levels and there are multiple stages where
You
you can
mind just
go ahead and
moving in with it? I think it's a little
a little
better.
bit more.
Yeah, I think, I think that's a
Is
lot
this
better.
better?
Yeah,
Okay.
it's a lot
Okay.
better.
Sure. So one of the things that we decided to do was we wanted both the request and the response logs, right? So just looking at the request that was coming in, it was not going to help us look at all of the potential threats. So we definitely did require the response logs, and we wanted to compare the response and see what was happening, which is why we decided to go with the request response approach. Now, some of the things that we decided to not log at all, if you observe right here, were some of the health checks. So as soon as we enabled health checks, and I did not know about this personally, but Kubernetes performs a lot. I mean, a ton of health checks, right? So it's going to keep bombarding your endpoint with a bunch of logs. And this is what ended up, giving us, or this was the reason for all of those 300,000 logs in under 30 minutes. So we looked at all of those logs, identified patterns, and decided, hey, you know what? These, at least for our specific use case, these are generating noise. So we did not want this as part of our entire system. So we decided to go ahead and not log it. But again, if you are going to be using this on a live cluster, do not go ahead and disable this. And additionally, I also have the audit webhooks right here. And this is what Abhay was alluding to earlier as well, right? So if you want to push something into a webhook, in Kubernetes especially, is you just create a manifest file and you say, hey, this is where I want to push all the audit logs to, and Kubernetes handles it for you, right? So you don't have to necessarily write your own logic to fetch the logs and push it somewhere else. All of this is automatically taken care of. And one final thing that you'll have to do, especially if you've set up your own Kubernetes cluster like we have, is you'll also want to change the API server manifest file. And this is typically going to be in the manifest directory. So if you head over to the manifest directory, and if we have a quick look at the API server manifest file, all I had to do to ensure that my logs were being pushed to my webhook was add these two lines that we have right here. I'm not sure why it's not highlighting, but the audit policy file that I have right here, where my cursor is, and the webhook configuration file where it's going to tell Kubernetes where to push all of these logs to, right? So this is all you need to do. And Kubernetes is now going to start pushing all the logs that you've asked it to push to a listener or to a webhook that you have essentially set up. So as soon as this is done, what we decided to do was we had two separate webhooks, right? So one was for the audit logs, and the other was for Falco. So I'm quickly going to show you the Falco configuration as well. And then I'm going to actually tell you how it all works together, right? So when it comes to Falco, I'm actually going to open it up right here. It's a lot easier. So this is going to be in Falco under the configuration. Falco, again, it allows you to go ahead and make modifications, configure where you want to push all of these generated logs to and all of that. One option that they provide, and I think that's on their website as well, is Slack, right? So if you want to go ahead and leverage the Slack webhook, you can do that. What we decided to do was the HTTP output, right? So we enabled it and we started pushing it to a listener that we had set up, right? So all the Falco logs were now being pushed to the other webhook that we had set up, and our system was essentially consuming all of the Falco logs as well. Now, again, with Falco, the other reason why I like Falco quite a lot is you get to have your own custom rules. It is a bit of a learning curve, but it's not really that hard to write your own set of rules. So we decided to write our own set of rules that Falco is going to be looking for, along with predefined rules, which is comprehensive in and of itself. These are some of the rules custom rules that we ended up writing, right? So the first one was the default service account rating. And this is something that I previously spoke about as well. So whenever you create a deployment, or whenever you deploy a pod on your Kubernetes cluster using the service account token, the token of that particular service account is automatically going to be injected in one of these two directories that we have right here. So whenever there's a read operation, we're going to go ahead and raise an alert or raise a flag, calling it as a potentially malicious behavior. Similarly, if we have a root container, right? So if any container is running as a root, ideally they should be running as non-root. So if any pod is running as a root, we go ahead and raise that as a potential flag as well, in case an attacker has gained access to the system and they're trying to launch their own set of pods on your Kubernetes cluster to either mine cryptocurrencies or perform any other malicious operation. So all of this, the way it all works together is all of this is first of all coming to our webhook, and from our webhook it then goes to our OPA, or the Open Policy Agent, which then returns a binary response. It's going to analyze these logs, especially the audit policy logs, the API server logs, and then it's going to say true, this is dangerous, or false, this is not dangerous. And based on that, we were only collecting the dangerous logs, because again, we did not want to overload our database and have all the unnecessary logs which we considered not to be dangerous as part of the database itself. So what we decided to do was identify the potentially dangerous ones and start storing only those for further analysis. So with regards to the rules, writing these rules, once you get a hang of Rego, is actually fairly simple, especially if you know the entire JSON structure that you are that's coming to you, right? So, and we did have a brief idea of what to expect. So, and this is something that Abhay previously showed on one of the slides as well. The first thing that we look for is anonymous access. If a user belongs to the unauthenticated group and the username is anonymous, then we go ahead and flag that as a potentially malicious behavior on our Kubernetes cluster, right? So anonymous user is trying to gain access or trying to run some command on some resource on our Kubernetes cluster. So we go ahead and flag that. The next one that we look for is rogue agents. Now, whenever you deploy something on your Kubernetes cluster, your kubelet and your flannel or your the core DNS, all of these components are going to be communicating with the API server. And you don't necessarily want to flag all of those behaviors, right? So what we decided to do was, if the agent is a kubelet, or if it's a kubectl, or if it's a sysdig for Falco, or if it's flannel, we said, hey, you know what? Don't flag any of that. But if the agent is something that does not belong to this list, something like a curl command or a HTTP request, right? So if it's some other agent, then I want you to flag it as a potentially malicious behavior to try and identify a rogue agent on our system.
So
the next one again, yeah.
In the case of agent, you mean user agent, right? So basically the
Exactly.
origination of that HTTP request. So in this case, it's the user agent. Okay, fair enough.
Yes. The next one is, again, service account that is used by rogue agents. Now, one of the attacks that we perform in our Kubernetes Security Masterclass training is we deploy this entire application stack on a Kubernetes cluster. Then we find a way to gain access to one of the pods that is running inside this Kubernetes cluster. And from there, we try and steal the service account token and then, pivot and, try and perform privilege escalation on the entire Kubernetes cluster itself. So this particular rule right here was to identify just that. So assuming an attacker manages to gain access to one of your pods running on your Kubernetes cluster, if the attacker knows what they're doing, one of the first things that they'll try and do is gain access to the service account token, leverage that, and then try to gain access to other resources running on your Kubernetes cluster. So what this essentially does is, if a user agent does not belong to the default set of user agents that Kubernetes uses, and if they're trying to leverage the service account token and communicate with the API server, then I want you to go ahead and flag this as a potentially malicious behavior as well, right? So this is one of the other things that we do. The other potential malicious behavior that we also look at is service account accessing other namespace. So in Kubernetes, what you can do, and for those of you who have used Kubernetes, I'm sure you're aware of this, is you can go ahead and create logical segmentations within your Kubernetes cluster, right? You can create a dev namespace, a prod namespace, a security namespace, staging namespace, QA namespace, and so on. So in this particular rule set that we've defined, let's say I'm the attacker right here, and I'm trying to attack Abhay's Kubernetes cluster, right? So I somehow gain access, reverse shell access to a pod that is running on Abhay's Kubernetes cluster, and this pod happens to be running on the default namespace. Now, if I steal that particular service account token, and if I start communicating with the kube system namespace, which is where all the control plane components are running, that is dangerous, right? So I'll try and gain access to either the HCD, or I'll try and gain access to the API server itself, or I'll try and gain access to some other sensitive namespace where they're running, where Abhay is probably running some sensitive workload. If I do that, so from the default namespace, if I try and gain access, or if I try and list out resources in other namespaces, that is a pretty dangerous behavior. So we go ahead and look for that as well. The other one is kind of self-explanatory. That is shell exec. If anybody tries to exec into a pod that's running on a Kubernetes cluster, ideally that should not happen. So we go ahead and raise that as a potential malicious behavior. And finally, we also have the service patch. So let's assume we have a Kubernetes cluster which has services running with cluster IP. Now, as an attacker, if I gain access to this particular Kubernetes cluster, what I want to do is try and gain access to the service from the internet or from some other network itself. What I can do is I can change, or I can patch the existing service and change it from either cluster IP to node port, or if it's a node port already, I can change it from node port to something like load balancer and get myself a public IP address. And this can be pretty dangerous, especially for tools or services that are deployed internally for your Kubernetes cluster, right? So I can go ahead and start exposing these sensitive services to the public internet and try and gain access to that. So this is one other thing that we currently look for as well.
Basically, I think all you have to do if you want to write out your own custom rules is extend this rules.rego file and you're off to the race, right?
That's pretty much it, yes.
So you don't have to, you are not necessarily hard coding anything. You're just leveraging the request data that comes in from the Kubernetes API server, or the log data that comes in from the Kubernetes API server that is sent to your socket. Your socket essentially pushes that to OPA that's running as a separate service as part of your infrastructure, and your infrastructure, OPA would come back with a yes and no response, or yes or no response.
Yes.
So
yeah,
okay, fair enough. Yeah, sounds good.
So again, we obviously wanted some sort of a UI to be able to look at what is happening and see what's happening, which is why Till went ahead and developed the entire user interface for us. And this is the high-level overview of what you can expect if you have, Kranthi deployed on your Kubernetes cluster, right? So again, this is running on a separate server somewhere. This is not running on my Kubernetes cluster, right? So ideally, you do not want your entire threat hunting framework to be running on the system where you are expecting threats, right? So that defeats the purpose. So I went ahead and people tend to do that, surprisingly. Anyways, so I went ahead and created a separate server for myself, deployed the entire user interface and the webhook and OPA and all of that good stuff. And this is what you typically see, right? So the Falco findings and the audit findings are currently separated. We do not want to merge that because, again, Falco is optional, right? So for our entire system, if you do not want to use Falco, you don't have to use Falco, right? So, and even when it comes to the Rego framework itself, like let's say you do not want to look for this entire service patch. All you have to do is either comment this line or delete this line. So this entire thing is extremely customizable to the way that you are going to be running your Kubernetes cluster, right? So you can essentially customize it the way you want it to perform or run. And finally, if you want to start digging into some of these logs, you just click on show.
Might just wanna zoom in a little bit because some of the text
on this as well.
Yeah, I think this is a lot better. Okay.
Probably a little bit more. Okay.
I think you've done dark mode by default, so I think there's no option of light mode.
There's no option of light mode. You're stuck with dark mode, and yeah. So here, currently, what it's trying to do is it's looking at Falco, which I had deployed, and Falco is trying to look at some of the namespaces. It's trying to get the namespace. I had previously deleted the namespace as well, so it's going to go ahead and it's going to start logging all of this stuff, right? So again, if you want to go into one of these logs and look at the entire request and response, you can do that as well, right? So here we have a user. The user is the Cube system, authenticated user, and this user was trying to access namespaces default Falco service. Right, so I think I've gone ahead and tried to create a Falco service, and it went ahead and logged this entire behavior for it. Now, similarly, one of the other things that we also want to start doing is give our own scoring mechanism, right? So try and give a score and give a score to tell you folks, how it pretty much how dangerous it can be. So these are some of the audit logs, and here we have the Falco finding logs as well. Somebody seems to be reading, probably me, the default service account token a lot, but it's going to go ahead, and priority is something that we get from Falco itself, so it kind of makes things a little bit more easier for us. But as soon as there is a privileged container that's launched, it's going to go ahead and notify us. If there is a root container that's running on the system, it's going to go ahead and notify us as well, right? So, and again, you can dig into all of these logs and perform further analysis if you want. So yes, so this is the entire user interface.
Right. So so I think one of the things that at least for me would be an interesting next stage for this project that we're going to open source is directly hooking up to things like EKS, or at least the more popular cloud managed Kubernetes services, because again, most of us don't run Kubernetes like this, right? So yes, this works for Kubernetes when you have complete control over the control plane, which you don't in EKS, GKE, any of these managed Kubernetes offerings. So I think being able to, I don't know whether, in fact, I don't think you can do this with DigitalOcean and things like that. You might need GKE, EKS, anything that gives you the Kubernetes audit logs. I'm not sure whether you can pull this off with your DO and stuff like that. You might have to do it in another way. But yeah, I mean, I think this is definitely something that is the next stage of this particular project. And I think, so one of the things that I was thinking of as you were showing us the demo was maybe have some kind of metadata for the OPA rules. So things like saying that this is CWE this with severity of the flaw, severity of the finding, things like that. Because that, I mean, we as a security industry thrive on severity, although sometimes that is messed up. But we thrive, we need to see high, medium, low in our analysis. I think some of it works. Falco, I think, does it out of the box. I think we'll need to have some kind of metadata notation to express this. So maybe that's something we can think about as well. But yeah, no, but I think in general, the approach for me definitely made a lot of sense. And I think it really brings out a lot of what we need in this particular one. I think it's quite unique because I don't think there's anything I'm not sure. Again,
Yeah.
Kubernetes is so fast changing that by the time we finish the sentence, there are 3 tools released for Kubernetes. So never know. But But I've not seen anything that specifically does this. I think it's quite an interesting. In fact, I think you can use this for access control checks. I think like what Audit RBAC has done, can I extend that to a certain extent? Maybe do that as well. So it can be used to do access control violation checks, things like, hey, this pod is trying to use this privilege, or is trying to is using this privilege that it's not supposed to use. So you clearly not done RBAC setup correctly. So you can, I think one of those things that we can do is do all of those kind of rules and try and figure things out. So yeah, for me, this is definitely making a lot of sense. All right. I think we've come to the end of our session here. And just a quick reminder for those of you who are interested in some of our training, AppSecEngineer, which is our training platform. We are right now offering a pretty huge 50% off because it's Cybersecurity Awareness Month. So definitely check that out. You get access to labs. You get access to labs like this, Kubernetes, AWS. You get access to an entire library for an incredibly low price. So definitely check it out. It's definitely worth your while. And if you're at Black Hat or any of the, I think Black Hat EU, we are likely to be there. I'm not sure whether we can be there in person, but if you're there, say hi. And if we catch up, definitely that's something we can do. Other than that, yes, that's it from me. Anything else you want to say, Nitin, before we close?
Not really. That's pretty much it. Again, we are going to continue developing this project and probably integrate a few more rules and, obviously clean up the project and make it a little bit more better looking in terms of everything, and then release it soon.
No, I think I don't think there's anything too wrong in terms of the look. I think, as always, we need to do something about the docs. Docs is always the thing that all projects
And the
generally.
database as well. Yeah.
Yeah, we probably have to start integrating with some, open source GraphDB or something like that. Some open source. In this case, we went with the serverless option, but that's something we can always do. All right, everybody. Have a great day, great evening, great afternoon, wherever you are checking this out from. Thank you very much, and we'll see you in our next live stream, which I think you should get the schedules on our social media. You can check out our Twitter, LinkedIn, and you should see a whole bunch of activities that we've planned now and through the rest of the year as well. All right. Bye-bye.
Goodbye, folks. Take care.
Thanks. Bye-bye.